Welcome to Ask and Learn.
For this problem, you need to be looking at the book. It's referencing a certain region and a certain line that we're going to be looking at as we generate a volume. So for this problem, we are looking at region 1. So that is the area, and I'm going to try to keep the same color scheme as in the book. That's the area under this line. Okay. And what am I going to do with that? I'm going to rotate it around the line BC. Well, BC is y equals 1. Okay, because this is B, this is C. So we're rotating it around y equals 1. So let me just put this on here. There's my rotation. So as I rotate this and I generate a solid, let's see what we have. If I just take a general piece, just a random piece right here, representative slice, this is going to be a washer because I'm going to have an empty space where that white is, and then once I hit the blue, I'll have that as it goes around. This is a washer. What is the volume of a washer? Well, a washer is going to be two circles. First, I have the outer circle, so I'll call that my big R. Pi r squared minus the inside circle, which is pi little r squared, times the height. Okay. If I want, I could also pull the pi out. I could say this is pi times big R squared minus small r squared times the height. That's how I find the washer method, or find the volume using a washer method. That's each individual washer. I could use that formula to find the volume, and then I stack all the washers up. So let's see what that looks like when we use calculus to solve an infinite sum of an infinite number of washers all stacked up. As I stack these washers, I'm going to be going from x equals 0 to x equals 1, which means I can pull the pi through. I'm going to have the r's, which I'm going to look at in just a minute, times the height. And the height is that little infinitesimal change in x, or dx. That becomes my height. So what are my two radiuses? Well, the largest radius goes all the way down to the x-axis. It's 1, and it's uniformly 1 all the way across this distance. So my capital R, the big radius squared, is just 1. So what is our small radius? Well, the small radius, and I'm going to put this in green here, is that line going from the origin up to point C, which is 1, 1. Well, if I think about what the equation of that line is, this intercept is 0. The slope goes from 0, 0 to 1, 1. The slope is 1. Or the equation is just y equals x. So as I go on that my representative disk here and I go down, I hit that green line, that's the line y equals x. So that radius is x, and I'm squaring it. So this is based on our washer definition. This is the setup for the integral that we're going to take to find the volume of that blue section rotated around the line y equals 1. So let's actually do the calculus. The integral of 1 is just x. The integral of x squared, well, we add 1 and we divide by that exponent, and we evaluate from x equals 0 to x equals 1. Starting at the top limit of integration, I get 1 minus 1/3. And I would subtract the lower limit of integration, but that's just 0. So I don't have to worry about that in this problem. So this is just 2/3 times pi, or 2 pi over 3.